Hey guys, sorry I haven't been in class the last couple of days. I have been feeling a bit under the weather. So I thought I would make this video to go through the first couple of problems that you guys are working on in class today, just to make sure you understand what's going on in calculating these potential and kinetic energy problems. So problem number one here, you need to get ready for school. You lift your 2.5 kilogram backpack up 1.75 meters over your shoulder. What is the potential energy gained by the book bag? So again, just always identify what information you're given in this problem. 2.50 kilograms being the mass, 1.75 meters being the height of this book bag. And we're looking for the GPE, the potential energy due to gravity. The equation for that is going to be mass multiplied by the acceleration due to gravity, 9.8 meters per second squared, and then multiplied by the height of the object. All we're going to really do is plug the information that we got into this problem. We have 2.50 kilograms for the mass, 9.8 meters per second squared for the acceleration due to gravity, and 1.75 meters for the height. When we multiply these things together and add them all up, we're going to get a total gravitational potential energy of 42.875 joules worth of energy, which will be our final answer for this problem. Okay. Number two, which is kind of part two from question number one here. You forgot to put your homework in your book bag, so out of frustration, you drop your book bag from question number one. How much kinetic energy did the book bag have right as it lands on the floor? For these types of things, guys, it's always nice to kind of like draw out a picture and think about how the energy moves from one spot to another. Always recommend you guys draw pictures when needed. So we have our book bag here, and we have the floor underneath it. This is our before. And afterwards, our book bag is just going to be off the floor, just right as it lands on the floor. So just before it hits the floor, that's where we want to consider this book bag here. So this is asking about the kinetic energy that the book bag experiences, and this is going to be a conservation of energy problem. We haven't talked too much about this in class at this point, but we have kind of seen that potential energy kind of turns into kinetic energy as an object falls down, and can be vice versa as a moving object goes up a hill or something to that effect. So on the before, we said that GPE in the previous problem was 42.875 joules worth of energy. And if we're still holding the backpack, it's not going to be moving yet, so should have 0 joules of kinetic energy at this point. For the second part here, if we look at the gravitational potential energy, this is going to be when the height of this object is going to be about equal to 0. It's going to be close enough to be 0 that we're just going to call that this is 0 meters. It's practically on the ground. If the height of this object is 0 meters, then that means that this formula, mass times gravity times height, is the old mass times the old g times now 0. And anything multiplied by 0 is always going to be 0. So that means that the amount of energy that we have currently from gravitational potential energy for this object is 0. And so since energy can't be created or destroyed, if we lost that energy in gravitational potential energy, it had to go somewhere. It turns out that as this object falls, it is going to be accelerating. It is going to get faster, and so the kinetic energy should be increasing to the point where actually the amount of kinetic energy is going to be the same as the old gravitational potential energy. And that's just because the total energy before should be the same thing as the total after in all cases. Now this is technically the end of this problem. This is what we know the answer is at this point. But I want to take this one step further because I know that this is going to be a part of this worksheet in a little bit anyway. If we wanted to know exactly how fast this object was going, we would just have to use the kinetic energy formula. We have kinetic energy is equal to 1/2 mass of the object times the velocity squared. So all we're going to do is try and solve for v here, try and solve for this velocity. First step for any of these types of things, always plug your numbers in before anything else. We have 42.875 for our kinetic energy after. It's equal to 1/2 times the mass, which was 2.5, times our velocity squared. We want to get velocity by itself, so all that we're going to do here is we are going to isolate the v and then get rid of the squared. So we have 1/2 times 2.5 is going to be the same thing as 1.25. So I'm going to go ahead and write that out first. 1.25 v squared is going to be equal to our 42.875. Now to get v by itself, what we want to do is do the opposite of whatever is happening to v. Since 1.25 is currently multiplying by the v squared, we're going to do the opposite of that to get rid of it. So if we divide by 1.25 over here, we're going to have 1.25 cancel out with 1.25, and we'll do it over here as well. Divide by 1.25. And all that this is going to do is get v squared by itself. So plug that into our calculator. We're going to get that v squared is equal to 34.3. Now we have the squared. If we want to isolate v, again, whatever is done to v, we just want to do the opposite. Opposite of taking the square of v is going to be taking the square root. So if I take the square root of this number, it's going to shoot out just v. And so I'm going to have v is equal to the square root of 34.3, which, plugging that into our calculator, and I'm going to round to 2 decimal places here, should be 5.86 meters per second. Okay. So again, this wasn't part of question 2. I was just walking you through how you would calculate the velocity when you do know the kinetic energy and the mass for this object here. Again, guys, hope that you don't have too much trouble going through these problems tomorrow during class. We had some practice with this in the lab already, so hopefully this shouldn't be too bad. We will go over this stuff together when I get back, and I am aiming to be back in school on Wednesday. So hope you guys have a nice day. Hopefully I'll see you tomorrow.